When water becomes the enemy, survival becomes chemistry. For most of human history, food preservation was not a matter of convenience. It was the difference between endurance and collapse. Before refrigeration, before chemical stabilizers, before vacuum-sealed plastic, survival depended on mastering one brutal fact. Bacteria need water. Remove the water and you remove life. That principle built empires, sustained armies, and carried sailors across oceans. It also produced one of the simplest yet most durable survival foods ever created: hardtack. This is not romantic nostalgia. It is applied chemistry. If you understand moisture content, vapor pressure, and thermal drive-off, you can produce a food product that remains stable for years without refrigeration. In this guide, we break down the science of desiccation, the precise flour-to-water ratio required to push moisture below the microbial threshold, the triple bake method that drives out residual vapor, and why modern preservative-heavy bread fails in comparison. The microbial threshold explains why ordinary bread rots. Bacterial life requires available water to grow. Scientists measure this using water activity, abbreviated as a W. Most bacteria cannot grow below a water activity of 0.90. Many molds struggle below 0.70. When water activity drops below 0.60, microbial growth becomes nearly impossible. That threshold is the goal of true desiccation. Modern bread contains significant internal moisture. Even when it feels dry to the touch, its internal water activity remains high enough to support microbial life. Preservatives can slow mold formation, but they do not eliminate moisture. The structure of bread, soft crumb filled with air pockets, traps vapor and encourages gradual microbial colonization. Hardtack operates on a different principle. It does not attempt to mask spoilage. It prevents it by removing the resource bacteria require. That difference is fundamental. The flour-to-water ratio determines the survival outcome. The base formula for traditional hardtack is deceptively simple: flour and water, no yeast, no sugar, no fat. The absence of fermentable sugars prevents unwanted microbial activity during preparation. The ratio matters. For effective desiccation, the mixture should approximate a ratio of roughly 3 parts flour to 1 part water by weight. This produces a stiff dough that binds just enough to form a cohesive mass without retaining excess moisture. The objective is minimal hydration. Too much water increases drying time and leaves residual vapor trapped in the core. When mixing, incorporate water gradually. The dough should feel firm and resistant, not elastic or sticky. Unlike modern bread dough, it should not be kneaded extensively. Overworking introduces heat and uneven hydration. The goal is uniform distribution without activating gluten networks for rise. After forming, roll the dough to approximately 1/2 inch in thickness. Thicker pieces risk internal moisture retention. Thinner pieces dry more evenly and reduce structural cracking. This ratio, combined with precise baking stages, is what ultimately drives moisture content below microbial viability. The first bake sets the structure but does not finish the job. The initial bake functions primarily to cook the dough and begin moisture reduction. So you want to bake at a moderate temperature, around 350 degrees Fahrenheit, for approximately 30 to 40 minutes. This stage evaporates surface moisture and begins internal vapor migration. However, this is only the beginning. At this point, the biscuit is still far from shelf-stable. Internally, water remains bound within the starch matrix. Removing it requires patience and repetition. After the first bake, remove the biscuits and allow them to cool completely. Cooling is not incidental. It permits internal moisture to redistribute. Vapor moves from the core toward the exterior during rest. Skipping this rest stage traps moisture. The second bake drives out deeper vapor. The second bake is lower and longer. Reduce the temperature slightly and bake again for another 30 to 40 minutes. This stage pushes moisture further outward. The biscuits will feel harder and lighter. Again, allow full cooling afterward. This rest period is critical. As the temperature drops, residual vapor continues migrating. The structure tightens. Starch retrogradation occurs, further stabilizing the matrix. If you weigh the biscuits before and after baking, you will observe a gradual mass reduction. That lost mass is water leaving the system. The third bake creates the metallic ring of true desiccation. The final bake is what transforms hard bread into a survival-grade ration. Bake once more at low heat, ensuring even exposure. This stage may extend slightly longer, depending on humidity conditions. When complete, allow the biscuits to cool fully. Once cooled, strike one lightly against a hard surface. Properly desiccated hardtack emits a sharp metallic ring rather than a dull thud. That sound is not folklore. It indicates minimal internal moisture and a rigid structure. At this stage, water activity should approach levels inhospitable to bacteria and mold. The biscuit becomes more mineral than bread. It will be inedible without soaking, but nearly impervious to rot. Store in airtight containers in a dry environment. Avoid fluctuating humidity, which can reintroduce moisture. Why preservatives fail where desiccation succeeds. Modern commercial bread relies on chemical preservatives to slow mold growth. Calcium propionate and similar compounds inhibit certain fungi. However, they do not remove moisture. They merely delay colonization. Additionally, modern bread contains fats, sugars and softening agents. These ingredients improve taste and texture, but create ideal conditions for microbial growth once preservatives weaken. The soft crumb structure retains humidity, especially in sealed plastic packaging. Primitive desiccation avoids this vulnerability entirely. By lowering water activity below the threshold for life, it denies bacteria and mold the conditions they require. It is not delaying spoilage. It is chemically preventing it. The trade-off is comfort. Hardtack is dense, dry, and difficult to chew. It must often be soaked in water, broth, or coffee before consumption. Yet that inconvenience is precisely what grants longevity. Applying 19th-century desiccation principles today. For survivalists, understanding desiccation offers independence from refrigeration and supply chains. With flour, water and heat, long-term food stability becomes achievable without synthetic additives. Begin by controlling humidity during preparation. Bake during dry weather if possible. Use an oven thermometer for accuracy. Weigh ingredients rather than estimating. After final baking, store with desiccant packets or dry rice in sealed tins to maintain low internal humidity. For historical enthusiasts, recreating hardtack provides tangible insight into maritime and military life. Soldiers and sailors depended on this ration for months. Its durability shaped logistics and campaign planning. Modern bread satisfies comfort. Hardtack satisfies survival. That difference reflects two philosophies of food preservation, chemical suppression versus environmental elimination. Why mastering desiccation is mastering resilience. Desiccation is unforgiving. It demands precision and patience. Yet it rewards discipline with longevity. In a world dependent on refrigeration and preservatives, this ancient method remains chemically sound. Water sustains life, but in food storage it is the enemy. Remove it thoroughly and time slows. Leave it behind and decay follows. For serious history buffs and survival enthusiasts, this is more than baking. It is applied science rooted in necessity. It is the brutal chemistry of survival.